This call is now being recorded.
Good morning, students. So in this video, I'm going to explain KL transform. So KL transform is nothing but Cornell transform. This is the Hotelling transform. In Hotelling transform, we have the two different types of transformation techniques for the images. The first one is KL transform. The second one is SVD transform, singular value decomposition transform. So in our syllabus, we have the KL transform. So here, KL transform basis functions are orthogonal eigenvectors of the covariance matrix of a data set. So that means in the KL transform, the image is approximated in terms of mutually orthogonal eigenvectors of the covariance matrix of a given input image. So here the algorithm, the first point is formation of vectors from the given matrix. Formation of vectors from the given matrix. That means take the matrix or consider the image that is of size n by n. So that means it is a n by n matrix. So further, we should split the matrix into the different vectors. Like we may split in either row matrices or column matrices. So okay, here that means, so if you take n by n matrix, we should split this n by n matrix into the n by 1 matrices. N by 1 matrices. Okay, right? So here n by 1 matrices. How many n by 1 matrices are there? N by 1 matrices are there. For example, if n is equal to 2, so we have the 2 by 2 matrix. So you just convert this 2 by 2 matrix into the two 2 by 1 matrices. Two 2 by 1 matrices. That means one is let it be x0. Another one is let it be x1. Right? So in this way, the given matrix is splitted into the different matrices or vectors. So after getting the vectors, the second step is determination of covariance matrix. Determination of covariance matrix. So this covariance matrix is represented as COV of x, that is equal to expected value of x transpose minus x bar transpose. Here x bar is the mean of the x, that is equal to 1 by m summation k is equal to 0 to m minus 1 xk, where m, capital M, is the number of vectors in x. So here find the sum of all individual vectors in x and then divide the each value, added value, to the total number of vectors in the x. So that means here that is the average value of x bar. So after getting x bar, do the transpose of x bar and then do the multiplication of x bar transpose. And then here E of x transpose. This is nothing but 1 by m summation k0 to m minus 1 xk transpose. By using this formula, determine E of x transpose and then substitute both here E value and x bar transpose. Then you can get the COV of x. After completing this covariance matrix of the x, determine the eigenvalues of the covariance matrix based on the characteristic equation COV of x minus lambda ki. Determinant value of that one should be equal to 0. So determinant of, so here first determine here COV of x, covariance of x minus lambda k into identity matrix with the same size of covariance of x, and then take the determinant and assign that one to the 0 and then solve to get the lambda values. So here this lambda value is nothing but a eigenvalue. Now determination of eigenvector of the covariance matrix. So from the eigenvalue determine eigenvector. Now, so here it has certain procedure, so that will be discussed in the problem. Okay, so from the eigenvalues determine eigenvector. Then normalization of the eigenvectors. So here also, here after getting the eigenvector, normalize after getting the eigenvectors from the eigenvalues, normalize the eigenvectors. Then you can get the different vectors. You just combine all the vectors, then you can get the Kl transformation matrix. So Kl transformation matrix, after getting Kl transformation matrix, so we should verify with the orthogonality condition. So here perform T transpose should be equal to I. That means here the symbol for the transformation matrix is T, that is equal to that is a transformation matrix. Now multiply this one with the T transpose, it should be equal to I. Right? So after getting this, by using this orthogonal transformation matrix, multiply this matrix with the given input image, then you can get the transformed domain representation of the input image, that is the Y. And then here you may include 8th point also like this. So after getting Y, so here from the Y, how can you reconstruct the X? So that is here reconstruction of input image or input matrix. So here use the formula, that is nothing but, so X is equal to T transpose Y. T transpose Y. By using this formula, determine X from the Y. So here this is the nothing but KL transform. So now we will see the problem here. The problem is perform KL transform for the following image. Or matrix. X is equal to right. So this is the question here. So how can you solve this one based on the KL transform algorithm? We will see. Right. So now solution. So follow the KL transform algorithm here. Step 1. Formation of vectors from the given image matrix. So here matrix size is 2 by 2 matrix. Matrix size is 2 by 2. Now here, how many vectors will be formed here? 2 vectors. Hence 2 vectors can be extracted from the given matrix. Okay, so now let it be x0 and x1. So one is, another one is x0 is 4 minus 1, x1 is minus 2, 3. Now note down the second point, second step. That is nothing but determination of covariance matrix. Determination of covariance matrix. What is the formula here? COV of x is equal to E of x, x transpose minus x bar transpose. Now here first determine x bar based on the formula 1 by m summation xk, where k 0 to m minus 1. So okay, here m. What is the m here? Number of vectors in x. Number of vectors in x 2. X bar is nothing but mean value. So here based on this equation, x bar is nothing but 1 by 2. Expand that summation. So summation k 0 to 1. 0 to m minus 1 means 1 xk. That is also equal to 1 by 2 x0 plus x1, 1 by 2 here 4 minus 1 plus minus 2, 3. Now the resultant one is nothing but 2, here 2, here is 1, 1. So after getting x bar, so do x bar transpose, that is equal to, so the resultant one is, do the multiplication here, then you can get this. So this is the x bar transpose. Now find E of x transpose. That is equal to, what is the formula here? 1 by m k0 to m minus 1 xk transpose. That means here 1 by 2 summation k0 to 1 xk transpose 1 by 2 x0 x0 transpose plus x1 transpose. So here substitute values and then simplify. Right. So this is equal to 10 minus 5. Simplify. And then you can get like this. Now COV of x is equal to, what is that? Here, take this expected value of x transpose and then do the subtraction with the mean transpose. Then you can get the answer 9 minus 6 minus 6 4. So this is the COV of x. Now, so going to third point. What is that? Determination of eigenvalues. Determination of eigenvalues of the COV of x, covariance matrix. So how can you calculate this one? Take the characteristic equation that is mod of COV of x minus lambda k I is equal to 0. It's okay. So now here, substitute here all the values in this determinant of, so what is the covariance matrix? This one minus lambda k, and take the same size of identity matrix with the covariance matrix, that is should be equal to 0. Okay, simplify this one. So you know that how can you calculate the determinant of a matrix? So after simplification, so you can get lambda k square equation. Then, so after simplification, you can get two values for lambda k. One is the lambda 0, another one is lambda 1 as 0, 13. So now here conclusion is eigenvalues of covariance matrix are that's it. Now next one is fourth point, determination of eigenvectors from eigenvalues. Determination of eigenvectors from eigenvalues of the covariance matrix. So here, so first eigenvector from eigenvalue. First eigenvector from eigenvalue 0. So, right? So, okay, here. So, you should follow the equation like this. Covariance of x minus lambda naught into I into phi naught is equal to 0. Right? So, use this equation to determine the eigenvector. Here, phi naught, phi 1 are the eigenvectors for the lambda naught, lambda 1 eigenvalues respectively. So, here, solve this. Substitute here and then solve. Now, here, substitute. Covariance of x is 9 minus 6 minus 6, 4 minus lambda naught is nothing but 0. Lambda naught is nothing but 0. Next one is nothing but, that means lambda naught into I is nothing but all zeros. So am I correct? So otherwise, I'm writing like this simply. Minus 0, I means this one. So here by product these two, you can get all zeros here. So okay, now that is into phi naught. So phi naught is equal to 0. So here phi naught is nothing but a column vector. So consider phi naught as like this. Phi naught is equal to, let it be phi 0, 0, phi 0, 1 like this. Okay. So now substitute here. This is 9 minus 6 minus 6, 4 into phi 0, 0, phi 0, 1 is equal to, here 0 means take here also column matrix 0, 0. So now here simplify this one and then find phi 0, 0, phi 0, 1. So, okay. Now here, so multiplying these two, 9 phi naught naught minus 6 phi naught 1 is equal to 0. Another one, minus 6 phi naught naught plus 4 phi naught 1 is equal to 0. So now here, after simplifying these two, so you may get phi naught naught is equal to 2 by 3. phi naught 1 is equal to 1. So try yourself, and then you can get like this. Check it once. Okay. So now phi naught is equal to 2 by 3, 1. This is the eigenvector for the lambda naught. So now, so going to the similarly, so do it for the another one. What is that? Phi naught 1. Phi 1. That means phi 1 for lambda 1. So here eigenvector phi 1. Next one. Here use the formula covariance of x minus lambda 1I into phi 1 is equal to 0. So now here substitute 9 minus 6 minus 6 4 minus 13, lambda 1 is 13, 1 0 0 1. Here 5 1 0 5 1 1 is equal to 0 0. Okay, simplify this equation here. Simplify. So then you can get two equations. One is minus 4 510 minus 6 511 is equal to 0. Then minus 6 510 minus 9 511 is equal to 0. So from this you can get 510 is minus 3 by 2. 511 is 1. Therefore, the second eigenvector 510 is nothing but minus 3 by 2, 1. Phi 1 is nothing but this one. Okay. Phi 1 is minus 3 by 2, 1. So, then here after getting two vectors, okay, right? So, phi 1, phi 0, phi 1, then you should normalize. Normalization of the eigenvectors of the covariance matrix. The first one is for eigenvector phi naught. So use the formula here. So 1 by square root of phi naught naught square plus phi naught 1 square. And take the vector. This is a normalization formula. Do this and then find and do this, find the normalization of phi naught. So then by you can get the answer like this 0.554, 0.83. Okay, so similarly, so find the normalization of this one. So based on the formula, what is that? 510 square plus 511 square, 510 511. So then you can get the normalization values minus 0.83, 0.55. Right? So here, this is the one here. After finding normalization of the eigenvector, find the Kl transformation matrix. Kl transformation matrix. T. So that T is nothing but combine the normalization value of the eigenvectors. The first one is 0.55, 0.83. So that means here join the column vectors to get the n by n matrix, like 2 by 2 matrix here. Minus 0.83, 0.55. Okay, so in this way, find the transformation matrix for the KL matrix. Okay, right? So now check the orthogonality here. Check the orthogonal condition. So orthogonal condition means here follow the condition P transpose should be equal to I. So follow this condition. So then 0.55, 0.83 minus is there. Here 0.83, here 0.55. So here, so do the product here, then you can get 0.99 something. Here also 0.99 something. So consider like this. Okay. Now, so here the orthogonal condition is satisfied. Now, apply this transformation matrix on the input image. So here KL transform of input matrix or image. So this is the what we found here, two-dimensional kernel or basis for the KT transform. So that is the T, capital T. So here so the 2D kernel is there. That's why I use the formula y is equal to T into X. So don't use A input image A transpose like that, since there A is the one-dimensional kernel, but here T is the two-dimensional kernel. Okay, it's okay. So now here substitute Tx, and then we may follow the method like this on also here. So here find the y0 and y1. So like the formula. So take the formula like y0 is Tx0, y1 is Tx1. Okay. So now y is nothing but y0, y1. So join y0, y1 column vectors. Then you can get the full matrix. So now what is the y0 here? The transformation matrix into x0. Now what is the output? So transformation matrix is 0.55 minus 0.83, 0.83, 0.55. Now here 4 minus 1, then calculate. Then this is equal to minus 3.76, 1.67. So now y1 is equal to the same thing. So okay, here use minus 2, 3. Here 0.55 minus 0.83, 0.83, 0.55. Now this is equal to 3.4226. Sorry, here. No, don't have here values like this, okay? Here in the Y naught, 3.03, here is 2.77. Here, minus 3.59, here, minus 0.01. Okay, now check the answers. And then now, what is the output matrix or transform domain of the input image? Y is equal to 3.03 minus 3.59, 2.77 minus 0.01. Okay, now here, so 8 point reconstruction. Reconstruction of input values from the Kl transformation matrix. Okay, T. Use the formula, this one. Okay, here also use x naught T transpose y naught, x1 as T transpose y1. Okay, so then simply get x is equal to, after getting x naught and x1, then now x is equal to, so almost equal to 4 minus 2 minus 1, 3. Okay, so this is the problem. How can you apply KL transform algorithm on the input image or matrix? Okay, in this way find the y, and also how can you reconstruct the x from that y based on this KL transformation matrix T. Okay, thank you.